Hi folks, it's Dan Friedman with Consensus Enterprises. As you can see, we have some lovely sketches of us. Just give me 1 second. I'm going to stop video to preserve my bandwidth. I'm coming at you live from Toronto, Canada. We're 3 Canadians here. 2 of us are in Toronto and 1's in Montreal. Consensus Enterprises is a veteran open source team of programmers, and we are old enough to call ourselves sysadmins. We do Drupal and Azure work. Azure is a back-end hosting system for Drupal. We've worked at all ends of the life cycle, front, back, early and late. Our focus these days tends to be on social enterprises, nonprofits, and in the public sector. For example, here are some logos of some of the folks that we've partnered with and continue to work with over the years. Today, we're going to be discussing a brief history of cloud computing to talk about how we got to the point we're at. We're going to be talking about some principles and practices that we encourage others to follow at Consensus, and we're going to be talking about some specific examples. Colan will be stepping in at that point to talk about Terraform and Ansible. And then Christopher is going to show us a demo of, and Christopher's going to step in to show us a demo of how it all works together. Then we'll hopefully have some time for questions afterwards, and we'll try and join you on Slack. But of course, before we get started, no presentation is complete without a XKCD comic. And this illustrates a really important reality of what people experience when they try to automate large numbers of things, which is they think they're going to be in the box on the top and work in, and have lots of time to work on other stuff, but then the automation actually takes over everything you're doing and becomes everything you do as you rethink all of your processes constantly. Now, the implication here is that what you're doing if you're in the bottom box is failing, but we'd like to argue actually that if you're in the bottom box, that means you're doing the right work first, and you're actually on your way to doing things the right way. So I strongly encourage you to find yourself in the bottom box, and we can talk more about that later. Another very useful chart that the XKCD guy produced is this one, which I recommend everyone prints out and pastes on their wall, which gives you the ratios between the amount of work you put in and the amount of time you save. And we do find that as we follow the principles and practices we're about to talk about, we do find ourselves migrating down and to the right on this chart, which is what you want. So here's a brief history of cloud computing. Now, if I understand correctly, most of the people I'm talking to are in government, and so you'll be very familiar with the shared computing model that things used to start out with, or that everything started out with in, let's say, the 60s, with mainframe computers in very large boxes that look like this, with lots of grainy photos and lots of colors because it was the 60s. Mainframes were the order of the day. All the computing was centralized and very institutional and controlled by a lot of very large companies like IBM. This meant that the expertise required to talk to these computers usually meant you had to have a PhD in computer science. It wasn't for the faint of heart or civilians. As computers got smaller and those boxes that they fit into got smaller, organizations managed to fit them into smaller and smaller shelves, which fit into smaller and smaller rooms. And I remember working in startups in the 90s where we had lots of colorful rooms like this. That was great until people realized that that meant if anything went wrong in that server room, like a flood or a disaster of any kind, that the organization was vulnerable to catastrophic data loss. And so through the early 2000s, people started to migrate into data centers where you could keep your eggs in more geographically distributed baskets, which was a nicer way to go. This also meant that some of that older commodity server hardware was getting cheaper, and as prices fell through the floor, large companies like Amazon and Google started buying up that hardware and then selling the shared computing resources to the public, to organizations at retail prices. And there we are. That is how we got back to a shared computing model and basically have come, in certain ways, full circle. Now, the reality of cloud computing has some benefits and some challenges. The benefits, of course, are that you can scale up and outward and make your operations larger at the drop of a hat or the click of a credit card. But what that means is that you might have some trouble controlling your costs. It's very flexible, you can add all kinds of things and build all kinds of new components, but that tends to increase the complexity as you have more and more components that have to interact in more exponentially more ways. And what that means is that we're actually back to an environment where it takes quite a bit of expertise to automate all the things, as we're talking about here, make all the components interact with each other, and actually achieve whatever business outcome, organizational outcome you're trying to achieve. So with that, what's an organization to do? How do we navigate the various pitfalls that can befall you? Well, we recommend that folks define their resources in code so that they start treating their computers as herds of cattle rather than cherished pets. This is a bit of a change for a lot of folks, but it's really useful in making your operations more efficient. We also want to make sure we keep our documentation in line. So you keep your description for humans as close to the code as you can, so that it's really easy to find, and so that your folks can figure out what each other were up to, or even figure out what you yourself were up to as recently as last week. I speak from personal experience. We also want to version control everything, make sure that you have an audit trail and you can reproduce whatever state you want. And you also want to keep the changes that you're making as small as possible so that you can refine your choices about what known state you want to get back to. The last piece in the puzzle here is to continuously test everything and to make sure that your testing is automated. This is one that people tend to overlook or forego due to time or budgetary pressure, but it's actually like taking your seatbelt off while you're driving. It's really important to keep your tests up to date and to keep your tests working so that you know in the highly complex universe of cloud computing and multiple components, as soon as you've broken anything, or as soon as you've broken any of those exponential interactions between all the things that you're trying to automate. So, once again, define all your resources in code, keep your documentation in line, version control everything, make small changes, and test continuously. And those are our 5 principles for cloud computing success. And I'm going to hand things off now to Colin Schwartz, my colleague at Consensus, to talk about Terraform and Ansible and how they support the strategy I've just talked about.
All right, hi everyone, Colin here. I'm going to talk about Terraform a little bit. So how does Terraform support an infrastructure as code strategy? So Terraform allows us to define infrastructure components and files written in Terraform language syntax. These files can, in turn, be committed into version control and thus handle the software. So if you look on the right, you can see the image here. That's what it looks like. So that's how you define a resource that you want in your infrastructure. So custom infrastructure as code configuration depends on Terraform providers and resources, which in turn depend on Go, which Terraform is written in. As you can see, we've got providers and then resources which depend on them. As providers provide resources, and then you have your configuration, which is the code you're actually writing to do this stuff. Great, so let's talk about providers. So a Terraform provider is responsible for understanding API interactions and exposing resources, which are the things you want to create. Examples of providers are OpenStack, Amazon Web Services, Microsoft Azure, Google Cloud Platform, DigitalOcean, and all those types of companies. So here's an example of the OpenStack one that you define. We've got an authentication URL in a region. As you can see, those are var.something, so those are variables, which I'll talk about later. But that's what you need to specify your provider. Now, there are 297 different cloud providers that Terraform supports out of the box, so that's quite a few. So if you've got a favorite one, I'm fairly certain that it'll be there. You'll be able to use it without too much trouble. If you want, you can click on the link when you're looking at the slides, and that'll take you to a big list in the registry that they maintain of all the providers. So let's talk about resources. So a resource is a thing you want to create at your cloud provider. Examples of resources are security groups, VMs, networking elements such as routers, floating IP addresses. This is a VM we have here on the right. Now, I mentioned variables briefly. So Terraform does support variables. So the format for that, when you're using it, is var.whatever, the ID. And you can see here we have some examples. You basically, create a little stanza, and you assign it to default. Normally is how it's done. In this case, these are UUIDs for images, which is, you know, the OS, or UUID for the flavor of the instance, which are the specs for the VM. Security groups. So good cloud providers will have firewall rules allowing access to resources which act as an allow list, preventing insecure access. So for example, your database servers, generally you would want behind some sort of firewall to prevent, you know, public access. So typically you'd only allow web servers, you'd only allow, say, your web service to access your database servers. You wouldn't want your database servers to be, you know, out there on the internet. So you can create different rule groups, and you can have different rules added to each group. So here's what that looks like. First, we're defining a group, which is the OpenStack networking secgroup v2 resource. So that's the type of resource that we want to create. And we're calling it web. And the description is web servers. So that's the group. Next, we've got two rules in there. So we've got HTTP connections, which is saying, okay, only allow connections on port 80 incoming. And we have another one saying only allow incoming connections on port 443, which is for HTTPS. So that's why this is the web server group. That's typically the group you'd set up for your web servers. And, you know, you'd prevent everything else, which is the default usually. So to define VMs, which is probably the thing that everyone's most interested in, this is an example of how to do that. So you can have different server types, and, you know, you define that by your security groups, your image, your flavor. So just again, I may have mentioned this, but your image ID would be your operating system, say Ubuntu. Your flavor would be, say, I want a 2 gig VM with 10 gig of disk, that kind of thing. You'd specify your key pair so you can log in using SSH. You'd say what network you want the VM on, and any dependencies. So in this case, we're depending on the VPN security group because this is going to be a gateway VM that's running the VPN server. That's the example here. Now, configuring VMs from within Terraform. So while infrastructure automation can be handled by Terraform, VM configuration can be handled by Ansible. They can work together in several ways. So Terraform can run Ansible playbooks, which is what we're going to do in today's demo. Ansible can also run Terraform code, which is the other way around. Or Terraform can provide a dynamic inventory of VMs that can be used independently by Ansible. So Ansible, you can run Ansible separately, not as part of a Terraform run. It'll just get the list of VMs that Terraform tracks with its state. So here's what that looks like. We have two stanzas here. The first one, it's specifying a dependency. It's saying, you know, we need to wait until the public IP address of this VM is available before we can SSH to it and configure it. That's how Ansible usually does its thing over SSH. The username is Ubuntu to log into it. And we're specifying the IP address. While that's a big, long thing, what that's really saying is as soon as the dynamically generated VM is created, because we don't know the IP address yet, it could be anything. When it is created, grab the address from that thing, from that resource. And that's what Ansible will use to log in. So as you can see, we've got a local provisioner, which runs a command, which is, sorry, that's very long, but basically it's running the Ansible playbook command. And as you can see at the end, VPN server.yaml is the code, the Ansible code that's getting run. So that's the playbook, and it's being run from a working directory, which is somewhere else. Now, to apply this infrastructure that you've created, you can run the Terraform apply command. So that'll commit defined infrastructure by making changes necessary to actualize the desired state. So when you run it, it'll take everything that you've defined in code and ask you, here are all the changes you want to make. Is this correct? Do you want to do it? I didn't show it here. This is just the end. It's asking you, do you want to do it, yes or no? But it gives you a big list of changes to make. And you have to confirm that you actually want to do it, which is always a good idea. And you type yes if you want to, and anything else if not. Terraform destroy does the opposite. It'll take down everything that you've defined. Now, I say managed by Terraform because when you run a Terraform destroy, it actually only takes down stuff that it manages. It doesn't take down any infrastructure that you've created manually. So say, on your cloud portal or whatever, you can manually create VMs, that kind of thing. This won't touch that. So if you've got stuff that's managed by Terraform and stuff that isn't, they don't have to interfere with each other. So you don't have to worry about taking any of that down. Saving state. So in order to keep track of IDs, metadata, Terraform stores that in several places. By default, it stores it locally in your .terraform directory. And now, because enterprise teamwork, you're working with other folks, they have this concept of backends where the state can be shared amongst various folks. So there are different types of ways of doing that. The way that the example here, we're using a Swift container, which is OpenStack's object storage. And we're specifying, here the name. There's a backup one, which is the archive one. And then we're telling, saying, here's where it is. We want it in region 1, which is in Nova Scotia. And here's the authentication URL for that. That's where we want to store state. So if I run Terraform and do a bunch of things, and then my team member wants to run it later, it'll make sure we're tracking the same thing. All right, so those are the basics for Terraform. I'll now let someone else take over. Christopher, I believe, is going to talk about Ansible.
Indeed. Give me a minute, and I will share
sure.
screen. So we're going to take a look at how Ansible supports infrastructure as code. Basically, Ansible is written in YAML, which we should all be familiar with because it's the config language for config files in Drupal as well. So that's a nice dovetailing of skill sets on that side. In this case, we're actually showing an example of defining a Linode server. So this is, you can, from within Ansible, deploy cloud infrastructure. In this case, though, we're going to be looking at examples during the demo of configuring a server that was provisioned with Terraform. While Ansible can do this kind of stuff, it's not its core functionality, and that is the case for Terraform. And so we find Terraform better when it comes to specifically the components around how it handles existing configuration or existing resources, making things more idempotent so that you can run the same scripts repeatedly and not have it, for example, create a new VM every time you run it. With Ansible, it's focused mainly on doing things like adding packages, so installing MySQL via apt or something like that, and deploying new config files for that and restarting services and things of that nature. That's sort of its core functionality, and it does that part really well. So that's why we continue to use it in that capacity. So Ansible itself is written in Python, so that's a dependency both on the local device that you're going to be running Ansible on, but also on each of the systems that it's going to be managing. Because with Python, it actually ships small Python scripts that are referred to as modules off to the remote server and runs them there. We then, as administrators, will find roles online or build them ourselves that combine that functionality so that when we say we want to apply a MySQL role, for example, it has the kinds of policies we want in place, right? We want to disable the default root password for the MySQL server, for example, things of that nature. Roles allow us to combine scripts together, Ansible scripts together in a way that does all of the configuration that we want all at once. And then we have individual configurations that we can do afterwards, and we can see some of those examples because there's sometimes some shims that are needed to kind of make things work smoothly together. We'll see examples of all of that during the demo. So I'm going to move on to just briefly speaking to the authentication and authorization components here. Both of these components are very key to building out an infrastructure. And so you're going to need to make sure that that's secure end-to-end and that only the people who are authorized to make any changes to this can actually do so. So I'll just briefly speak to that model. So essentially, there is a step 0 here that I'm not looking at in particular, but essentially what it comes down to is that the user has to have a key of some sort. And in the case of Terraform, it's going to be, in our case, an OpenStack RC file, which basically defines access to the cloud resources that we have. So when, and that's basically our account at the OpenStack provider that we work with. It would be very similar with AWS or GCE, where you load that into the environment in which you're running your commands, and then Terraform will pick that up and use it as it goes. So the user triggers the call, that then hits the API for the, in our case, OpenStack, which authenticates us as a valid user. It then ensures that my user account in that system has access, usually via roles, similar to how Drupal works, to create and manage those kind of resources. And then it goes ahead and executes the tasks on the basis that I do have that authorization. What we see with Ansible is something very, very similar. The difference being that it's handled at more of an OS level. So when I run Ansible, it's going to SSH into a remote server that it's going to then apply the configuration to. That is secured by SSH, and so I need to have an SSH key to grant me access to that VM. Now, that's kind of pre-baked into creating the VM, so that's kind of how it gets injected in the first case. But that's basically the authentication component. Authorization then happens at the next step, which would be that Ansible, when it's running certain things, like say installing a Debian package, needs to have sudo access in order to have to be able to run those commands. So as normally what you would do is either run that as a user, such as the Ubuntu user on an Ubuntu server that has pretty much universal sudo access, or you can limit it to, say, an Ansible user, as an example, where you can actually craft policies in sudo that would limit its access to what kinds of changes it can make to the system. So, for example, you might want to have firewall rules on the server that are pre-baked into an image or something to that effect that Ansible cannot change because it's maybe managed by a different team. Once that authorization happens, then it goes ahead and runs that particular module. And so that part kind of happens on a case-by-case basis wherever there is a need for it to ensure that it's authorized to run that kind of stuff. So with that, we're going to switch to a demo. So bear with me for a second. I'm going to stop sharing, and I'm going to switch over to a terminal. Actually, before I do that, I'm going to show you the end state that we want to have so that we can then tear that down and rebuild it. Basically, what we have here is this is the interface for our cloud provider. And I'll just show you that we have just a couple of instances running currently. We have an Azure server, and it's this one here. It's presenting this. Azure is the system that we use for managing Drupal sites on top of the VM infrastructure that we build out. And it allows you to deploy code bases, install sites, run automated backups, do upgrades, etc. It automates a lot of that kind of stuff. We're not going to go into a lot of depth about it, but just to show you that this is what our target is for the infrastructure deployment that we're going to do. As you can see, we have that instance here, and there's other resources that are a part of this. So there's a volume, for example, that's attached to that server. We're going to have over here some network components that have been built out. So here's our main network. And then let's see, another one that's useful and worthwhile looking at is the security groups that we have in place, for example, right? So these are things that what we're going to do immediately here is switch over to my terminal now, and we're going to destroy all of that. And the purpose of destroying it here is to just illustrate how easy it is to build it up after it's been sort of cleaned out. So what we're going to do is we're going to call Terraform, and we're going to call destroy. Oops. And similar to what Colin alluded to earlier, it's going to examine all the state that it has, so all the information it has about the current situation, and then it's going to give us a plan for what it's about to do. So it's going to say that each of these resources is going to be destroyed and we can verify everything that's in here. Now, in this case, bear in mind, it's a lot of stuff because we're destroying the entire sort of micro deployment that we have for this demo. Usually, this would be something much more limited. You might take down one VM out of a cluster, for example, and so it would be easier to kind of see what those differences are going to be. Now, this is going to take a couple minutes, but essentially what it's doing is it's going to just go through and tell, as we were looking at before with the API calls, it's making API calls out to the OpenStack provider, telling it to destroy these various resources. It parallelizes that fairly well because there's a lot of these resources can be taken down at the same time. In some cases, you do have dependencies between them. So the OpenStack API won't allow you to delete a volume that's attached to a VM, for example. So what we're going to see is that the only part that takes any time generally with this is when you're working with volumes, because there are actual physical disks that have to be formatted and put together in a way that's going to allow it to be attached to these cloud VM instances. And so that's the part that has an actual physical component. The disks actually run. Otherwise, it's fairly quick to go through. So we're going to see that this volume 1, which is now the last remaining thing, is going to take a little while. So I'm going to switch over to another terminal and just briefly look at how this stuff fits together. So if we look in our example here, this is all available in our talks repo that we make available. We've got a bunch of these Terraform scripts, and then here I just have some of the components that are required. So here's that RC file that has the credentials for our account in it. I have an actual binary for Terraform just running right here, and then we've got our various Terraform scripts. So the one that's probably the easiest to kind of grok in here is the virtual machines one. So this is similar to what we saw earlier with colan. So this defines the VM that we're going to be running, and then this defines that volume that's currently being destroyed, and then this defines how that volume gets attached to the VM. And then there's a few other things that happen afterwards in terms of assigning a floating IP to the VM, right? So that's kind of how these things fit together. A lot of times we're going to be referring to other resources to pull together the IP address, for example, or the ID to make references back and forth between these components. I'm going to quickly look at the provisioners component, which is where we actually run Ansible from. So we saw the last bit here where we actually run Ansible, but prior to that, we define this whole thing as a cluster as a resource so that we can add dependencies. We want to make sure that the volume is attached to the VM and that the public IP address has been assigned to it before we go ahead and try to do the Ansible run, which depends on SSHing into the machine to do its thing. So if we don't have the public IP address available, for example, we're not going to be able to proceed, hence the dependencies here. We then have, we define the connection that we're going to use, and then we do a little test here, basically, where we're going to ensure that we do actually have the ability to SSH into that machine by a remote exec, which basically just means it's going to execute this command on the remote server in this case. And then what we do here is where we start getting into the Ansible component itself. So Ansible Galaxy is, there's a site, galaxy.ansible.com, that's similar to Drupal.org, where we have all of our Drupal modules listed. In this case, it's all of the publicly available Ansible roles. And there's a command line tool that would be similar to Composer that compiles those together into the ones that you're going to need for your deployment. So in this case, we're going to run that. It's by convention called requirements.yabl, and that will fetch the role that we need. So we're going to, I'm just going to switch back over here because now we've destroyed all that those resources. If we were to look at the front end, we'd see that all of that has been dropped out of the OpenStack UI, and that site, the server running Azure, is no longer available. So what we're going to do now is we're going to do the opposite of destroy, which is the apply. step. And then while that's running, we'll switch back to looking at some of these things. So similar to what we had before, when we were destroying these things, we now see all of the resources that are going to be created. This is comparable to like a diff, right? In a Git diff, in that it's showing that it's going to be adding these resources. A lot of the attributes of these resources, it's not going to be able to know until it's been created. So you don't have IDs for resources, for example, until they actually exist. So we're going to just go ahead and say, yes, this is what we want to do. And it's going to start creating these resources. So you can see that it triggers all of them in parallel and then reports back in sequence as things occur. It also lets us know when things are taking a while. So every 10 seconds, it'll report back on each of the resources that it's creating. So you can see here that this volume is still creating, for example. What we'll note as we go through here is that everything else will be created, and then we'll see that the volume, as I mentioned earlier, is the slowest thing to create, and so that'll be the final thing that we see several instances of as it goes. So what it's doing here is a little bit opaque in that it's not giving us much detail on it, but essentially we're creating an entire very small basic network with firewall rules, a default network with a subnet in it, a router. We've got a volume that we're creating and we're attaching it to a VM, right? We then have a public IP address that we're assigning to make the whole thing available via the internet. So here we're going to see that it's running the volume creation. This takes a couple minutes. So I'm going to quickly switch back over here and take a quick look at the requirements component of Ansible Galaxy, which is going to be one of the next things that it runs once that volume is created. So over here we have our Ansible code, and in here we have requirements. Now in this case, we only need one role to do the kind of deployment that we're doing today. So we only list the one. This happens to be one that we use, that we've kind of customized, and we like to specify a specific commit just to make sure that when we have multiple of them that we're getting the exact code that we want to have as we go. So let's check in over here. It's still creating. Once it builds out the roles, we're going to then see it call the playbook. And a playbook is basically where how Ansible runs through these things. So it's actually prompting me for my key, for the password for my SSH key. So that indicates to me that it's moved on to the next pipe. So here we see that it's actually starting to run Ansible. So as Ansible runs, it'll report back each of the tasks that it's accomplished. So in this case, it's, let me take a quick look up here just to show you that it did the Ansible. So here's where it's running Ansible playbook. Previously, it should have run Ansible Galaxy, and that's where it installed the role that we were just looking at. So this will proceed, and there's a lot of output here because we have it on with some debug output to kind of just show the depth of data that we're getting back from Ansible as it proceeds. And in this case, it's actually running the playbook that we could look at momentarily. So it's actually this here. And essentially, we just specify that which hosts we want to run this on, which remote user to connect as, and then a couple of other specific things. In this case, the newer VMs don't have Python installed, Python 2 installed. So we just need to tell it to use Python 3. And then a couple of things that we're going to pass to the Azure role as variables to configure it the way that we want. Down here, we have the actual role that we're going to apply. And in this case, we're doing some of those shims that I mentioned. So in this case, we're going to wait for the volume to be attached. So we basically just, Ansible provides a module, that's what this part here would be, that allows it to just wait for this path to exist. So it'll pause briefly if the path doesn't exist, waiting for it to have been attached. In this case, we then format it and mount it so that it's available for us to use to install Azure onto afterwards. And then we do a quick apt update to make sure that we have all the local repos available that we need for installing the various components we're going to install. And then it proceeds to apply the role, which has basically just a whole set of these kinds of tasks that are required to install Azure in this case. So let's switch back over here, and we'll see that it's continuing to write through to go through these different steps. In this case, Azure runs on Drupal 7 still, so it's writing a custom makefile that will pull together the various components that we want. And then very shortly, it's going to hit an apt install for the Debian package for Azure. So here we are with the package. And this is going to take about 5 minutes. So at this point, what I'd like to do is open it up for questions. We can then pause that briefly once this is complete, and we can just show that everything is in place as we described and showed earlier. So with that, are there any questions in the chat? There's a question about what the difference is between this and DevShop. So I'll address that. DevShop is a distribution that's built on top of Azure. So Azure itself is a Drupal distribution that includes a suite of modules, a suite of drush commands, an install profile, and a theme that provide that system that we saw initially, right? With all the capability of installing sites, upgrading them, backing them up, etc. DevShop extends that to focus, instead of on hosting, to focus more on development workflows. So it has integration with, I believe, with GitHub and with some CI tools, and does more automation on the sense of triggering rebuilds of new platforms or code bases when you've got a new commit to a Git repo, for example, right? And it'll kind of work through stuff on that basis. John Pugh, who just asked a question here, is the maintainer of DevShop, so he would be able to answer some of that at some point as well. We do have a buff in the afternoon about some of these things, but yeah, there you go. This is basic. This is just a default out-of-the-box Azure installation in this case.
Yeah, thanks, Chris. And I think it's also like kind of a different scope, right? Because what you're running here is like command line, Terraform, right? It's kind of a different level of the stack, right? DevShop, like we're starting to automate more with DevShop, but it's like it's much more focused on the developer experience and giving people the fastest way to develop the sites.
Right.
So more, yeah, in terms of, I wasn't sure what you're talking about specifically, Salim, but like Azure and DevShop are kind of equivalent in the context of this talk, right? It's like the tool running inside to run all the Drupal automation, right? Rather than this is like the Terraform handles the whole platform and the servers and then installs that, right?
Exactly.
There's no GUI here?
Not for this component, no. For this stuff here is the deployment of the infrastructure and the installation of the applications that are running on it.
Yeah, I think the purpose of this, right, was to show kind of to really show the hands-on way to use Terraform, right, and to
Right.
Yeah, Terraform's
really get a hand. Like I think that's great because you need to know how it works. But anything that you run as a command, you can kind of automate and build into a UI for it, right? So, like for example, I have built Docker support in Azure and other types of support. It's not that difficult to, once you identify the command and the metadata you need to inject in there, that's kind of the thing. Azure is actually more of like a Jenkins if you want to treat it that way, in that you can build out modules that will run whatever task you want, whatever command you want. So it's more of a, I think this talk was definitely more of like the hands-on, that was the context of it. But we could talk more about it off later.
Yeah. So the question is from Prana saying, does it rebuild the entire infra each time, even when the regular build happens? So by it, I'm assuming, Prana, that you mean Azure itself. So Azure is not running this. Christopher's been running it by hand. Azure is not a front end for this. So this just builds the server that hosts Azure. So it would rebuild. So Terraform could rebuild the entire infrastructure each time if you wanted to. It's largely a question of what you have configured.
Yeah, typically, if you try Colin here, if you try rerunning, if you've done a Terraform apply and you've built everything and you run it again, it's going to say there's nothing to do because stuff's already been built up, right? So let's say you had half of it run and you run apply, it'll finish off what wasn't done before. So that's Ansible works the same way. It'll only change things that need to be changed, which is great because you're not, because if you do an apply or an Ansible, you do the same kind of thing. It'll just do what it needs to do to get to where you want to be, right? So it keeps track of all of that. And there was a question about Kubernetes a little bit further back. I don't know if we got to any plans for going to Kubernetes for the infra. Maybe you talked about this. I joined late. So yeah, Christopher, do you want to?
Sure. Kubernetes isn't. This would be useful to be able to, for example, deploy Kubernetes, right? Kubernetes runs applications for you and provisions the containers and orchestrates all of that. It doesn't provision hardware, cloud hardware, for example, or do this level of configuration. So generally, this would be a level below that. So Kubernetes would do things comparable to some extent to what Azure does in terms of building the components that are required for an application. It does that in a context of a containerized environment, right? So there are plans in the future to do some further work with Kubernetes around some of this stuff, but that's not any of the stuff that we're looking at specifically today.
Yeah, you can take Terraform and Ansible and build out a Kubernetes cluster with it. I mean, that's really what we're trying to show here. You build up an entire infrastructure using these tools, right? You can run whatever you want, Kubernetes, not Kubernetes. Right? So.
Yeah.
Yeah, and I think I've heard that Jeff Geerling's Ansible role for Kubernetes is like the easiest way to launch Kubernetes. I've seen tweets where it's like, I run one command and I launch my Kubernetes and then I destroy it. And thank you, Jeff Geerling. You know what I mean? So there's an actual tested Ansible role that actually does the install for Kubernetes. So Terraform would launch the servers and then Ansible and then potentially launch Kubernetes as well.
Yeah.
So it's kind of a wild world.
Yeah. Exactly.